All right, so we're going to still continue with our topic on interest, and we're going to go back to simple interest today because from simple interest, we can pull off a different formula, well, a related formula, where we could find out how long something, or by what rate something grows or decays. Okay, so this is considered a simple interest. Now, our simple interest was found by taking our principal and then adding our rate. But of course, what can happen is we can continue that over the course of several years or hours or days. So there'll be a time factor here. So when we find our interest using a growth problem or a decay problem, it's principal times 1 plus the rate to the exponent of time. The R is still the rate. So that is our percentage. I'm going to use 5 again as a decimal. So if it was 5, you would scoop it twice and you would put in 0.05. And our T is our time, depending on the question. You'll see in the next one that it's talking about hours. Could be days, could be months. The rate is important because now these questions are going to either grow with interest or decay with interest. If the population size is growing, it would mean that the rate that we're putting in is positive. If our population size is decaying, it would mean that our rate would be negative. So growth would be a positive rate and decay would be a negative rate. All right, so let's look at one of each. All right, so number 2 on page 5. The population of fruit flies is increasing at a rate of 22.5% per hour, increasing. If the population has an original size of 10 flies, what will be the population after 1 day? Okay, so this is simple interest because it's not talking about compounding like in number 1. Number 1 talked about it compounding annually. And it's not saying the words compounding continuously. So because it's missing those catchphrases, it has to be final balance. And our balance in this is flies is equal to principal times 1 plus the rate to an exponent of time. All right, so this is increasing at a rate of 22.5% per hour. So I'm going to scoop this twice and I'm going to put it in as positive. I'm starting with 10 flies. Starting with 10 flies. I'm increasing, so I'm going to put plus, at a rate of 0.225. Okay, now be careful with the time. They're telling you after 1 day. I'm not going to put a 1 in time because my rate is hours. So because my rate is per hour, my time has to be measured in hours. This is different from the compound formula because the compound and continuously formula, our time was in years. So this is allowed to be anything it wants, but it has to match. So after 1 day, meaning 24 hours have passed. All right, so now I'm going to plug this in and I'm going to find out what is my population after 1 day, 24 hours. So I have 10 times 1 plus 0.225 raised to the 24. So after 1 day, my population, it doesn't tell me where to round, considering it's a fly. I'm going to have to round to the whole fly. Now be careful here. 1,000, I'm going to write my whole number, 1,303.965583. Okay, so after the 24th hour, we have 1,303.9 flies. So we haven't quite got to 1,304. So my answer, even though this 9 tells me to round up, because I'm talking about flies, I can't make 0.9 flies. I'm going to stay at 1,303 flies. All right, now let's look at a decay question. So if you go to page 7, number 8 is a decay question. So number 8 talks about a bacteria that's decaying at a rate of 20% per year. Okay, see years, they match. So I'm not going to have to convert anything. If the amount of bacteria starts out as 148,000, how much bacteria would there be left after 4 years? And left because it's decaying. Okay, so my initial amount is 148,000. And my rate is decaying by 20% per year. So I'm going to change this into a decimal. And then I'm going to say I'm decreasing at a rate of 0.20. We want to know what's left after 4 years. I'm going to put 4 here because, again, the per unit here matches the measurement here. So I don't have to change anything. All right, so now we're going to type that in. 148,000 times 1 minus 0.2 raised to the 4th. So I get 60,620.8. So again, I stay. I don't round up. I'm going to have 60,620 bacteria left.